Good evening. Hi. Good evening, gentlemen and ladies. You are welcome tonight, class. Tonight, we'll be talking about differential equations. Please try and inform others that we have started the class. We'll be talking about differential equations in calculus. Excuse me. When we say differential equation, a differential equation is one that contains differential coefficients. Is that clear? Example, like as you can see, example I, you will see with me that we have here a dy over dx plus by equals to 0. I d square y over dx square plus 4y equals to 0. I dy is equals to x plus 2y close bracket dx. Like this one, as it is, by the time we divide through by dx, this is how it will be. Dy all over dx is equals to open bracket x, or leave the bracket like this. Can you see now? So it is also a differential equation. Sometimes you might see some differential equation in this form. Are you following? Is that clear? Then IV d square y over dx square plus 2 dy over dx plus 3y minus 7 sine x plus 4x equals to 0 is a differential equation. Then you see with me here that differential equations are classified according to the highest derivative which occurs in them. What is this driving? That is telling you that it classified according to the highest derivative. So let's fix idea with this example 4 here. This example 4, amen. Example 4, I'm going to explain this. I'm going to explain it. Okay, so let's go ahead to explain the last sentence that says differential equations are classified according to the highest derivative which occurs in them. So, okay, let's look at this. Let us have a very short, let's say d square y all over the x squared. Please mind you, it is not written this way. Please, this is wrong. Take note. Are you following? Are you following? This is what? Wrong. This is how it is written. D square y all over the x squared. And it is not like this. Dy, students, you people are very funny. This is wrong. This is wrong. Take note. Are you following? So, okay. So this is the right way of writing this and this. Okay. So far so good. So let's look at it. Dy all over the x plus 4y equals to 0. You can now see that the highest derivative in this differential equation, we have d square y over dx square, and we also have dy over dx square, two of us. So As it is, this is known as second order DE. We call this a second order differential equation. Why? Because it is what? D squared all over d squared dy all over the x squared. Is that clear? So it is known as what? Second order. Why this dy all over the x all over the x equals to 4x. We call this is a first order DE. This is means differential equations. Take note. Are you following? Are you following? Right? So then what if you see something like this, d cubed y all over the x cubed plus d square y all over the x square. Let's say this is A, this is B, C, dy all over the x plus y equals to. What is the highest derivative? You can now see that the highest derivative here is what? 3. True or false? It's 2, right? So we now call this is known as what? Third order DE. Is that clear? So please always take note. This is third order DE differential equation. Are you following? So take note. So whenever you are asked to identify the derivative of the following differential equations, you'll be able to identify two of us. This is second order, this is first order. Is that clear? So take note. So we are going to I can clean this, right? Yeah. So always take note. So let's consider first order differential equation. Okay, so example of first order differential equation 1, where we have d square y all over dy plus y equals to 4x. This is the first order differential equation, or the notation can be y prime plus y equals to 4x. No, I taught you of this, true or false. Or it can be in this form, y dot plus y equals to 4x. True or false? True, right? True or false? It is true, right? Yeah. It seems you people are not much here. Why? What is happening? Over 300 students. It's only 9 students that are available. Why? What is happening? It's okay. So far, so good. Let's proceed. So, whenever you are asked to give example of first order differential equation, sometimes you may be asked to write down first order differential equation, give an example. You can write it in this form. Sometimes too, you can have y prime plus y equals to g of x. Then it means this is the same thing as dy all over dx plus y is the same thing as g of x, right? Or this is the same thing as y dot plus y is equals to g of x. So these are first order what? Examples of first order derivative. Or 3, you may have d equals to x plus y dx. This is the first order. By the time you divide through by dx, you will see the first order. It's a first order. Is that clear? Even as it is a first order differential equation. Oh, my camera, sorry, I think is network. Is network, yeah, should be network. Should be. Okay, so far so good. Let's now consider this is first order 2, second order differential equation. Okay, differential equation. Agree with me that examples are 1. You may see whenever you see d square y all over the x square plus dy all over the x plus y equals to 0 is example 1. This is the same thing as this is the same thing as y prime prime plus y prime plus y equals to 0. Or this is the same thing as y dot plus y dot plus y equals to what? 0. This is a differential, this is second order differential equation, and likely see them in your HND 1 second semester. You are going to do what we call advanced calculus. Is that clear? So as you can see, I think there is no need for us to go beyond second order differential equation because people are in ND1. But at least you are satisfied, you are okay with this. Yeah, at your level, you are okay. Is that clear? When you get to HND1, at least I will teach you or expose you with third order differential equations. But at least I have explained third order differential equations, two of us. So, any question before we proceed further? Do you have any question? Any question? No question. So can we proceed? You don't have question? Can we proceed? If there is no question, we can proceed, right? Please invite others to be part of the class. Invite them. Okay. Let's proceed. Let us proceed to consider okay, let me also show you, well, it's not necessary, sure. You can clear. Let's consider what we mean by order. When we say order, the order of a differential equation is the order of the derivative of the highest order. The order of a differential equation is the order of the highest derivative, right? Is the order of the highest derivative appearing in it. Appearing is E, appearing in it. So I'm going to explain this with this. D squared y all over the x squared plus the y all over the x plus y equals to 0. Alright, everybody should look at the board. Okay. Yeah. As you can see, when we say order of a differential equation, this is order, this is order. Is that clear? But you can see with me that this order is just what? Raised to power 1 here, two of us. But this order here is d squared, the x squared, two of us. So if now we want to talk about the order of this differential equation, we are going to talk about the highest order. So what is the highest order? You know that 2 is greater than what? 1. 1 is less than 2. So, true or false? So this order of a differential equation is what we call second order DE. Is that clear? Are you following? Okay, so now if you are following, what if we have d all over the x plus y equals to 4x? So who can identify the order of this differential equation? Please write it in the comment section. I'll give you 1 mark. Who can identify it? Yes. Israel, Luca. Identify the order of that differential equation. Who can identify it? Nasiru Ahmed. Nobody to identify that differential equation. Is it a second order or first order differential equation? Nobody? It's okay. This is a first order differential equation. First order DE. First order differential equation. Now you see now. So that is that. So let's consider degree of a differential equation. Please write it down. These things are very important. What you are doing here. The degree of a differential equation is that of the highest power. The degree of a differential equation is that of the highest power. Of the highest derivative which the equation contains after simplification. Derivative which the equation contains after simplification. Okay. So we'll fix idea with example how we can identify a degree of a differential equation. Is that clear? Are you following? The degree of a differential equation. Please, you better sit down and copy all these things. Okay, so now let's fix idea with example. Let us fix idea. Okay, example. Let's have, for example, b squared y all over the x squared open bracket raised to power 5 plus dy all over dx open bracket raised to power 8 y equals to 0. So if we are to classify this differential equation into degree, let's define what degree is all about. The degree of a differential equation is that of the highest what? Power. Highest power. What do you mean by power? Power means when you have either x raised to, this is power. The power of x is what? 8, right? Of the highest derivative. So when we say highest derivative, look at this. What is inside this bracket? Then look at what is inside this bracket. Which one is the highest derivative? You agree with me here that. You agree with me here that. Oh, this is a. You agree with me here that this one is the highest derivative compared to this. True or false? It's true. Because this is d square y over the x square, why this is dy all over the x. So as you can see, you can now see that the highest power, the highest derivative, carry what? A power. And what is the power here? 5. So the degree of this differential equation is, you now write what? Degree 5. Degree what? 5. Do you understand? Any question? Degree what? 5, right? Yeah. Degree 5. Okay. So let's fix idea with more examples. More examples. Okay, dy all over the x raised to power 10 plus 3y equals to 4x. So now, if you are asked to identify the degree of this differential equation, it's simple as ABC. Always know the meaning of the degree. Is that clear? As long as differential equation is concerned, know the meaning. The degree of a differential equation is that of the what? Highest power of the highest derivative. It means any power that the highest derivative carries in that equation, that is the degree. Is that clear? Of that differential equation. So if you can see what I am saying, the highest degree here, this is the second order differential equation, true or false? Because d square y over the x square. But here we have dy over the x square, open bracket, close bracket, raised to power what? 10, true or false? But if you can see what I am saying, who can tell us the degree of this differential equation? What is the degree? What is the degree? So what is the degree? What is the degree there? No, Okonkwo, did not get it. I know you people are blind mathematically. I will open your eyes. The degree is not 2. Think well again. Think well. The degree is not 2. Okay, to save our time, if I were you, you bracket it, you see that the power it carries is an invisible one, true or false? So the degree of this differential equation is what? Degree 1. Degree 1. Do you agree with me? Yeah. I just want to confuse you guys. That is why I did not bracket it and leave it like this. Degree 1. Okay. So let's proceed further to consider what we mean by solution. Solution of a solution of a differential equation. A solution of a differential equation. Amen. Amen. A differential equation is a function y that satisfies the equation. Is a function y of sometimes x, it depends on the independent variable that satisfies the equation. Satisfies the equation. Is that clear? That satisfies the equation. Are you following? That satisfies the equation. Then let's consider, take note of all these definitions you are seeing, very important. So let's consider general solution. Excuse me. General solution a solution to a differential equation which contains general solution, right? A solution to a differential equation differential equation which contains one or more arbitrary constants. Of integration is called the general solution. It's called the general solution of the differential equation. Take note of the differential equation. Take note. So tonight we'll be looking at, we'll solve some examples tonight. Are you following? We'll solve some examples tonight. That is first order differential equations using separation of what? Variables. Is that clear? First order differential equation. We are going to solve first order, first order differential equations. First order differential equation using separation of variables. Separation of variables, right? Okay. But before we begin to solve first order, first order, okay, let me just write it this way. First order differential equation using separation of variables. Is that clear? Okay, so we are going to solve some examples here, but before we go ahead to solve some examples, I will just show you how to integrate. Is that clear? Always show you how to what? Integrate. How to integrate first. So let us define integration mathematically first. Is that clear? Integration. Because it's more of integration, right? We want to define integration mathematically. Amen. Integration, when you have functions of this form, this is ax raised to the power of n dx. So if we are asked to integrate this, want to define integration, it means what we have here, n. Is that clear? We are going to write ax raised to the power of n plus 1, then use it to divide n plus 1 plus any constant. It could be k, b, a, but let it be capital letter. Is that clear? So this is the definition, mathematical definition of what? Integration. Is that clear? So let's fix idea with the example. If you are asked to integrate 2x raised to the power 2 dx, so it means this will be, what is this? This is your n, true or false. So here will be 2x raised to the power of 2 plus 1 all over 2 plus 1 plus any constants. Do you agree with me? Any question? Any question? Do you have any question? Any question? Do you have any question? Because we are going to somewhere that will make us to come back here. that will make us to come back here. So, do you have any question? Yes or no? No question? No question? Okay, let's proceed. So, what if you have integration? You are asked to integrate x raised to power 4 dx. So this means that this is your n, right? So n plus 1, x raised to the power of 4 plus 1, all over what? 4 plus 1 plus any alphabet, either A or this. So this is how to what? Integrate. But whenever you are asked to integrate the x, take note, the x will always give you x plus any constant, either k or b or a or d. Is that clear? Take note of this, very important. You are asked to integrate the x, it will always give you. So likewise, if you are asked to integrate the y, it will always give you what? Y plus any constant. Are you following? Always take notes. Whenever you integrate dy to give you dy, if you integrate dy to give you y plus any constant, if you integrate the x, it will give you x plus any constant. Likewise, if you integrate the t, you are supposed to have t plus any constant. Is that clear? Take note. Very important. Are you following? Are you following? Okay. So far, so good. Likewise, if you are asked to integrate 1 all over x dx, it will always give you in x plus any constant. Take note, very important. Then, likewise, if you are asked to integrate cos x dx, this will give you what? This will give us sine x plus any constant. Likewise, if you are asked to integrate sine x dx, you are going to have what? Minus cos x plus any constant. Take note. We will make use of all these things. So take notes. Is that clear? Hope you are following. Okay. So if you agree with me, let us go ahead to solve. Oh, taking the lights. So we'll call it a day. I think it just took the lights. Sorry about that.